High-bay fluorescent lighting systems can experience reduced lumen output at temperatures above 35 degrees Celsius, which is 95 degrees Fahrenheit. In industrial environments where ambient temperatures can exceed this threshold, light output may be compromised. Metal dust can accumulate on lamp surfaces and refractors, blocking light transmission. This can significantly reduce light output and impact visibility. To mitigate temperature issues, consider these steps. Firstly, use high-temperature fluorescent lamps designed to maintain lumen output at higher temperatures. Secondly, install fans or other ventilation systems to circulate air and reduce ambient temperature. To mitigate dust accumulation, these strategies can be helpful. Firstly, regularly clean lamps and refractors to remove dust accumulation. Secondly, consider using enclosed fixtures with gaskets or seals to minimize dust ingress. Thirdly, explore air filtration systems to reduce dust particles in the air. Fluorescent lamps require more frequent lamp replacement than high-intensity discharge lighting. Fluorescent lighting is generally more energy efficient than high-intensity discharge lighting, but energy savings may be offset by increased maintenance costs. High-bay fluorescent fixtures should be designed for industrial environments with robust construction and dust-proof features. Some industrial facilities have successfully implemented high-bay fluorescent lighting in environments with elevated temperatures and dust contamination by implementing the above mitigation strategies. However, others have encountered challenges with lumen degradation and dust accumulation, resulting in reduced light output and visibility issues. When choosing fluorescent lighting, high temperatures and dust contamination must be carefully considered in an industrial environment. Implementing appropriate mitigation strategies and evaluating the specific conditions of your plant is crucial to determine if fluorescent lighting is a suitable solution. Consider a detailed lighting plan. This will allow you to calculate the ideal number of light fixtures required for the plant. When calculating, ensure that you meet minimum lighting level requirements such as OSHA standards. Consider the ballast factor of the light fixture. The ballast factor is the percentage of light output a ballast allows to pass through a fluorescent lamp. Ballast factor can range from 0.7 to 1.2. A ballast with a high ballast factor can operate the lamp at a higher light output. Consider the type of light diffuser. A light diffuser helps distribute light from a light source more evenly. There are many types of light diffusers available, including prismatic, opal, and clear. The type of diffuser you choose will affect the overall light level and appearance of the lighting system. Consider the color rendering index of the light fixture. The color rendering index is a measure of how accurately a light source renders colors. A light source with a high color rendering index will render colors more accurately than a light source with a low color rendering index. The color rendering index is measured on a scale of 0 to 100, with 100 being the most accurate. Consider the correlated color temperature of the light fixture. The correlated color temperature is a measure of the color of light emitted by a light source. The correlated color temperature is measured in Kelvin. A light source with a low correlated color temperature will appear warm, while a light source with a high correlated color temperature will appear cool. When you decide to replace your existing lighting, consider doing a lighting audit. A lighting audit can help you identify areas where you can save energy and improve lighting quality. A lighting audit will also help you determine the best type of lighting for your needs. Use a qualified lighting professional. A qualified lighting professional can help you choose the right lighting system for your needs and install it correctly. A lighting professional will know the requirements of the National Electrical Code, or NEC. For example, the National Electrical Code Section 410.130. G1 states that the marquee of Class P ballast shall include a minimum ambient temperature as determined by tests. They will also know the requirements of underwriters' laboratories, or UL. Use only listed and labeled equipment. Listed and labeled equipment has been tested and certified by a qualified testing laboratory, such as Underwriters Laboratories or Intertech. Listed and labeled equipment meets all applicable safety standards. A lighting professional will also ensure compliance with local building codes. Use lighting controls. Lighting controls can help you save energy by turning off lights when they are not needed. Lighting controls can also be used to dim lights to reduce energy consumption. Lighting controls include occupancy sensors, daylight sensors, and timers. Consider the use of occupancy sensors. Occupancy sensors can turn off lights when a room is unoccupied. Occupancy sensors can be used in offices, conference rooms, and other areas that are not always occupied. Consider the use of daylight sensors. Daylight sensors can dim light when there is sufficient natural light. Daylight sensors can be used in offices, schools, and other areas that have access to natural light. Consider the use of timers. Timers can be used to turn off lights at a specific time of day. Timers can be used in parking lots, warehouses, and other areas that do not need to be lit all night. When deciding on what light to use, consider light-emitting diode or LED lighting. LED lighting is the most energy-efficient type of lighting available. LED lighting can save you up to 75% on your energy bill. LED lighting also lasts much longer than other types of lighting. LED lighting can last up to 50,000 hours. LED lighting is also more durable than other types of lighting. LED lighting is resistant to vibration and impact. LED lighting is also available in a variety of colors. LED lighting can be used to create a variety of lighting effects. LED lighting is more expensive than other types of lighting, but the energy savings and longer lifespan make it a worthwhile investment. LED lighting is also better for the environment. LED lighting does not contain any mercury or other hazardous materials. Consider the temperature rating of the luminaires. In locations where the temperature exceeds 35 degrees Celsius, which is 95 degrees Fahrenheit, you will need to ensure the luminaires and components are rated for the specific temperature. Look for markings on the luminaires and components such as the ballast. When selecting an LED high bake, consider the thermal management design, ensuring adequate heat dissipation to maintain optimal performance and lifespan in high temperature environments. Consider the light output of the light. The light output of a light is measured in lumens. A lumen is a unit of luminous flux, which is a measure of the total amount of visible light emitted by a light source. The higher the lumen output, the brighter the light. Choose lights with a high lumen output for areas where bright light is needed. The light output required for a particular area depends on the size of the area and the type of activity that takes place in the area. For example, a warehouse will require more light than an office. Consider the power consumption of the light. The power consumption of a light is measured in watts. A watt is a unit of power, which is a measure of the rate at which energy is used. The lower the wattage, the less energy the light consumes. Choose lights with a low wattage to save energy. Consider the voltage of the light. Voltage is the electrical potential difference of pressure that drives electrons through a circuit, measured in volts. Typically, industrial facilities use 480 volts, 277 volts, 208 volts or 120 volts. Ensure that the lights you select match the voltage of your electrical system. For instance, a 277 volt light can be used on a 277 volt circuit. The voltage of the light should be compatible with the voltage of the electrical system. Consider the current draw of the light. The current is the rate at which electric charge flows past a point in a circuit measured in amperes or amps. Ensure that the circuit breaker protecting the lighting circuit is adequately sized to handle the total current draw of all the lights on that circuit. This prevents overloads and potential fire hazards. For example, if you have a 20 amp breaker, make sure the lights do not exceed 80% of that capacity according to the National Electrical Code, or NEC. In this instance, that would be 16 amps. Consider the ingress protection, or IP, rating of the light fixture. The ingress protection rating is a measure of how well a light fixture is protected against the ingress of solid objects such as dust and liquids such as water. The ingress protection rating is expressed as two numbers, the first number indicating the level of protection against solid objects and the second number indicating the level of protection against liquids. For example, a light fixture with an ingress protection rating of 65 is protected against dust and water jets. Select light fixtures with a high ingress protection rating for areas where there is a lot of dust or water. Consider the ambient temperature rating of the light fixture. The ambient temperature rating is the maximum ambient temperature at which a light fixture can operate safely. Select light fixtures with an ambient temperature rating that is appropriate for the environment in which the light fixture will be used. Consider the color rendering index of the light fixture. The color rendering index is a measure of how accurately a light source renders colors. A light source with a high color rendering index will render colors more accurately than a light source with a low color rendering index. The color rendering index is measured on a scale of 0 to 100, with 100 being the most accurate. Choose light fixtures with a high color rendering index for areas where accurate color rendering is important. Consider the correlated color temperature of the light fixture. The correlated color temperature is a measure of the color of light emitted by a light source. The correlated color temperature is measured in Kelvin. A light source with a low correlated color temperature will appear warm, while a light source with a high correlated color temperature will appear cool. Choose light fixtures with a correlated color temperature that is appropriate for the environment in which the light fixture will be used. Select appropriate mounting heights and spacing to achieve uniform light distribution and optimal light levels on the work surface. Consider the potential for glare and take measures to minimize it, such as using fixtures with appropriate shielding or optics. Ensure that the lighting system complies with all applicable safety standards and regulations, such as those set forth by OSHA and the National Electrical Code, or NEC. Consider the maintainability of the lighting system, including the ease of access for cleaning and lamp replacement. Implement a regular maintenance schedule to ensure that the lighting system is operating at its optimal performance. When designing the lighting system, account for the potential for future expansion or changes in the layout of the facility. Consider the use of a lighting control system to optimize energy savings and improve lighting quality. Consider the use of a building automation system to integrate the lighting system with other building systems, such as the HVAC system. Ensure that the lighting system is properly grounded to prevent electrical shock hazards. Install surge protection devices to protect the lighting system from power surges. Inspect the lighting system regularly for any signs of damage or wear. Replace any damaged or worn parts promptly. Keep the lighting system clean to ensure optimal performance. Use appropriate cleaning methods and materials to avoid damaging the light fixtures. Properly dispose of any used lamps or ballasts. Follow all applicable regulations for the disposal of hazardous materials. Keep records of all maintenance and repairs performed in the lighting system. This information can be used to track the performance of the lighting system and to identify any potential problems. Consult with a qualified lighting professional for assistance with the design, installation, and maintenance of the lighting system. A lighting professional can help you choose the right lighting system for your needs and ensure that it is installed and maintained properly. They can also help you save energy and improve lighting quality. Consider the use of a lighting design software to simulate the performance of the lighting system before it is installed. This can help you identify any potential problems and make adjustments to the design as needed. Consider the use of a lighting measurement device to verify the performance of the lighting system after it is installed. This can help you ensure that the lighting system is meeting your needs and that it is operating efficiently. When dealing with dust, consider the material compatibility. Ensure that the chosen lighting fixtures and components are resistant to corrosion or degradation from exposure to metal dust. Select fixtures with a smooth, easily cleanable surface to facilitate dust removal. Consider the use of compressed air systems for regular cleaning of lighting fixtures in dusty environments. Provide adequate ventilation to minimize dust accumulation on lighting fixtures. Consult with a qualified industrial hygienist to assess the potential health hazards associated with metal dust exposure and implement appropriate safety measures. Consider the use of personal protective equipment, or PPE, such as respirators and gloves, for workers who are involved in cleaning or maintaining lighting fixtures in dusty environments. Provide training to workers on the proper procedures for cleaning and maintaining lighting fixtures in dusty environments. Consider the use of a dust collection system to remove dust from the air before it can settle on lighting fixtures. Implement a regular dust monitoring program to track dust levels and identify areas where dust control measures need to be improved. Consider the use of a dust suppression system to reduce the amount of dust that is generated during manufacturing processes. Consider the use of a dust-tight enclosure to protect the lighting fixtures from dust. Ensure that the dust-tight enclosure is properly sealed to prevent dust from entering. Inspect the dust-tight enclosure regularly for any signs of damage or wear. Replace any damaged or worn parts promptly. When using compressed air for cleaning, ensure the compressed air is dry and oil-free to prevent contamination of the fixtures. Establish a written cleaning schedule and procedure to ensure consistent and effective dust removal. Consider the use of a vacuum system with a HEPA filter to remove dust from lighting fixtures. The HEPA filter will trap the fine dust particles and prevent them from being released back into the air. Consult with the lighting fixture manufacturer for recommendations on the best cleaning methods and materials for their products. Implement a lockout/tagout procedure before performing any maintenance or cleaning on lighting fixtures. This will prevent accidental energization of the fixtures and ensure the safety of workers. Store spare lamps and ballasts in a clean and dry location. Protect the spare parts from dust and moisture to prevent damage. Keep a log of all lighting fixture maintenance and cleaning activities. This log can be used to track the performance of the lighting fixtures and to identify any potential problems. Consider the use of a drone with a camera to inspect lighting fixtures in hard-to-reach areas. The drone can be used to identify dust accumulation and other problems. Consider the use of a thermal imaging camera to detect hotspots on lighting fixtures. Hotspots can indicate a potential problem with the fixture, such as a loose connection or a failing component.